All right, Algebra 2. We're going to go ahead and do this next lesson, 1.6. Some of this is going to be review, if not all of it, so we'll see how much you remember from Algebra 1. All right, so the first thing we're going to do is evaluate the following expressions for the values of x and y. Here we're going to use just order of operations. When we substitute a number in to evaluate, we want to use parentheses to help us out. Right, so it's good practice to use parentheses. All right, so on the first one, 2x minus 3y, we're evaluating that when x is 4 and y is negative 2. All right, so we'll go ahead and substitute those numbers in. So 2 times 4 minus 3 times negative 2. So 2 times 4 is 8, and then minus 3 times negative 2 is negative 6. And here we have this double negative, so 8 minus negative 6 is really 8 plus 6, and so that's 14. All right, number 2, same thing. Let's go 5 times 1 minus 6 divided by 3 times 1 plus 2 times 6. All right, now with the fraction bar, you have to do everything on top and then everything on the bottom. And so everything on top, we have to, again, use order of operations by doing multiplication. So 5 times 1 is 5 minus 6. On the bottom, 3 times 1 is 3 plus 2 times 6 is 12. And then we have to do, again, everything on top. So 5 minus 6, we're going to simplify to negative 1. And 3 plus 12 is 15. Now this fraction, negative 1 over 15, doesn't simplify, so we're just going to leave it just like that. All right, evaluating for function at a given value. So it says find f of 5 given f of x equals 9x minus 1. So 5 is the x value. All right, and so what they're telling you to do is substitute 5 in for all the x's. So f of 5 is equal to 9 times 5 minus 1. Now f of 5 is just telling you where to evaluate it. It doesn't mean f times 5. So the left side we're just leaving alone. It's the right side that we're going to simplify. So again, order of operations. 9 times 5 is 45 minus 1, and so that's 44. So f of 5 is equal to 44. And then let's go ahead and do number 4 also. Same thing. Find f of negative 2. All right, so f of negative 2 is equal to negative 2 squared minus 3 times negative 2 plus 1. All right, so negative 2 squared means negative 2 times negative 2, so that's positive 4. Negative 3 times negative 2 is plus 6 plus 1. 4 plus 6 plus 1 is 11. All right, evaluate the function given the graph. All right, so here number 5 says find f of negative 5. Now, negative 5 is the x value of some coordinate. Now, what we're trying to do is find out what is the y value when x is negative 5. So we're going to go over to the graph, find negative 5 on the x-axis. So negative 1, 2, 3, 4, 5. Here's negative 5. And we want to find the intersection point. So we're just going to go up or down and find out where does it intersect as we move up or down. And so we have to go up to find that intersection point, which is right there. All right, now we're going to just go across and find the y value. And so that's 1, 2, 3. All right, so f of negative 5 is equal to 3. And that's because this coordinate right here has a coordinate negative 5, positive 3. And negative 5 is x, and 3 is the y value. And we're trying to find the y value. All right, and then let's find f of 3, same thing. So go to positive 3 on the x-axis. So 1, 2, 3. Find the intersection point. Here it is right there. And that point is 3, 0. And so f of 3 is going to be 0. Again, that's x, and that's your y value. All right, piecewise functions. It's just a function that's written using two or more expressions. Typically, we'll use rays and lines to show the graphs, but you could use a whole bunch of other types of graphs also, parabolas, circles, or whatever. So a ray, remember from geometry, is kind of like a line, but it only has one endpoint and then one arrow. So it's an endpoint with one arrow. And then a line segment doesn't have any arrows, but it has two endpoints. Okay, so it has two endpoints. All right, so number 7, graph each piecewise function. All right, so f of x equals x minus 3, and then f of x equals 2x. So if we look at the inequality that's associated with x minus 3, it says x has to be less than or equal to 1. All right, and then for the other one, f of x equals 2x, that says x has to be greater than 1. So those values for the inequality, that says those are the only x values that you're allowed to use to graph that ray or segment. All right. So what we're typically going to do is make an xy table for each function, and then we'll pick x values, substitute them in, find the y values, and then we can go ahead and plot it. All right. So you can see I made these two xy tables with their two functions that are given to us. So we have f of x equals x minus 3 and f of x equals 2x with their xy tables. So what you're going to do for each function, so the first one says f of x equals x minus 3, x has to be less than or equal to 1. We're going to take that number, whatever they give us, and that's going to be the first number in your xy table. All right, and we can see on the second one, f of x equals 2x, that says x has to be greater than or 1. So that number right there has to be the first number in the xy table. Sometimes they're the same number, sometimes they're different. But whatever numbers they are, those are have to be the first x values in your xy table. All right, and so to get some other x values to help us graph, what we're going to do is look at the inequality for each of them. All right, so now we go to the inequality. So on the first one, for the x minus 3, if you look at the inequality, that says only pick x values that are less than or equal to 1. I'll use blue so it's associated. All right, so smaller than 1, we could pick anything you want smaller than 1. So it could go 0, -1, -2, -3, anything you want, as long as it's less than 1. Then on the second one, f of x equals 2x, it says only pick x values that are greater than 1 or bigger than 1. So you can pick anything you want greater than 1. So here I'll just pick 2 and 3. All right. And so now what I'm going to do is take each of those x values and I'm going to substitute them in for x in their equation to get their y values. Okay, just plug them in for x to get their x to get the y values. All right, so let's take each one. So I'm going to first start with the x minus 3. So I'm plugging 1 in first. So 1 minus 3 is -2. 0 minus 3 is -3. And -1 minus 3 is -4. All right, and now we'll go over to the f of x equals 2x, xy table, and we're going to plug 1 in, 2 in, and 3 in for x, and then find the y values. So 2 times 1 is 2, 2 times 2 is 4, and 2 times 3 is 6. All right, so now in your xy table, you want to always look at the first ordered pair, the top one. That first point is either going to be open or it's going to be a closed circle. Okay, now most of them are all going to be closed, but you're going to get probably one that's an open circle. And so the inequality is going to tell you which one it is, open or closed. All right, so again, let's go to this first one. Go back to the original, just so you can see on f of x equals x minus 3. It says x has to be less than or equal to 1. Since it has an equal sign next to the 1, that first coordinate has to be closed. All right, so that's why I wrote closed. Now on the second one, f of x equals 2x, x has to be greater than 1. It doesn't have an equal sign under the inequality. So that means the first coordinate has to be open. All right, and so that's why I wrote open. All right, so now let's go ahead and we can plot this. So we'll do the first one. f of x equals x minus 3. So we're going to plot each of those points. So at 1, negative 2, so that's right 1, down 2, that's closed. 0, negative 3, so we're just going down 3, closed. Everything else is closed, but it's just the first point can be open or closed. Negative 1, negative 4, so it's down here. So this first point, 1, negative 2, that's the point, that's the end point of our ray. And everything else, the arrow has to go through those. All right, so this is what this ray is going to look like. Okay, this again is the end point, because it's the first ordered pair in the XY table. All right, and then the next one, we'll go ahead and graph that one. So first 1, 2, so right 1 up 2. Now this is going to be an open circle first. And then 2, 4, that's closed. 3, 6 is closed also. All right, again, that 1, comma 2, that first ordered pair, that's our end point. All right, so this is our end point because it's the first ordered pair. All right, and then the arrow goes through all the other points. All right, and that's it. All right, so let's do this last one. So here we have 3 functions we're graphing. Now, if you look at the inequalities for each function, it'll kind of tell you if it's a ray or if it's a line segment that you're graphing. If it only has one inequality, then it's a ray. And if it has 2 inequalities, then it's a line segment. So you can see why I wrote ray for the first one, a line segment for the second one because there's 2 inequalities, and then a ray for the third one because there's only 1 inequality. So we make an XY table for all 3. And so instead of f of x, I wrote y. All right. So f of x equals x plus 2, I wrote y equals x plus 2. And then same for the other 2. Y equals negative x, and then y equals 6. All right, so then for the first function x plus 2, it says x has to be less than negative 2. So I'm going to start my xy table with negative 2. Again, that's because of that number right there. Then on the second expression, y equals negative x, it says start with negative 2, but then end with positive 1. All right, so I'm going to end my xy table with positive 1. And then on the third one, it says x has to be greater than or equal to 1. And so again, I'm going to start my xy table with positive 1. All right, so now I want to fill in my x values. So let's go back to the original and see which inequality it's facing. So on the first one, x plus 2, it says only pick x values less than negative 2. So we can pick anything we want less than negative 2. So let's go negative 3, negative 4. All right, and then on the second one, it says x has to be between negative 2 and positive 1. So it's got to be bigger than negative 2, but less than 1. So we're going to pick x values that are in between those. So negative 2, what's that, negative 1, and 0. All right, so we start with negative 2, but we end at positive 1 on the x values. And then the third one, it says x is greater than or equal to 1, so we want to pick x values that are bigger than 1 this time, and so 2 and 3. All right, and then we're going to just go ahead and substitute each of those values in, and then find their y values. All right. So the first one is x plus 2, so negative 2 plus 2 is 0. Negative 3 plus 2 is negative 1. And negative 4 plus 2 is negative 2. Then the second one, we're substituting in for negative x. So remember when you put negative 2 in for x, there's really a negative already in front of it. All right, so it's negative 2, so that's going to be positive 2. And then negative 1 is positive 1. Negative 0 is just 0. And then negative times 1 is negative 1. All right, and then the third one, this says just y equals 6. So there's no numbers to actually substitute in for x. I mean, there's numbers, but there's no x. And this says that y has to equal 6 every single time. That's what that means. So all we're going to do is write 6 in for every y position. All right, and now we can see which coordinates are going to be open and which ones are going to be closed. Again, that's all based off the inequality from the original problems. So on the first one, it says x has to be only less than -2. So our first coordinate is going to be open because there's no equal signs. On the second equation, it says at -2, there's an equal sign, less than or equal to, so we want to close that circle when x is -2, but because of the 1 has an inequality that doesn't have an equal sign, the 1 is going to be open. All right, so again, there's the -2, the -2, and then the 1 and the 1. All right, so open and close. And then the last one, x is greater than or equal to 1. All right, so it has an equal sign, and so we want to close at the 1. All right, so now we can go ahead and plot all this stuff and connect them. All right, so we'll do the first one. It's array. So we'll plot -2, 0 with an open circle. -2, 0. -3, -1, so that's left 3, down 1. That's closed. Everything else is closed. -4, -2. All right, and then connect them with array. Then the next one is a line segment. So we'll plot -2, 2. So that's left 2, up 2 with a closed circle. -1, +1, 0, 0, 1, -1, and that's open. We'll connect them. That's our line segment. And then the last one, 1, 6, is closed. So right 1, up 6 is closed. 2, 6, 3, 6. All right, and then the first point, 1, 6, is the end point of the ray, and so then the ray goes through all the other ones. All right, and so then that's how you graph it. So the hardest part probably is just setting up the XY table and picking the correct X values. Remember, you always start with the X values that are given to you in the inequalities for your each XY table. Those are your starting numbers, and then based off the inequality, less than or greater than, those are the other X values that you're going to pick. All right, and so that's it.